Okay, we're going to talk about polynomial functions and their models of real-world problems. And I'm going to do this a little different in the book. It talks about different models can work for different things, and they actually talk about how to do it by hand or all that kind of stuff. So, like on here, you can use a polynomial function to model many real-world situations. The behavior of the graphs of polynomial functions at different degrees can suggest any type of polynomial that best fit the particular data. So if you look at this set of data here, let's just talk about this a little bit here. This data here, you had these points. Well, if we draft it linear, it looks like that, which is not a very good data. If we graph it quadratic, well, it's a little bit better. If we graph it cubic, that looks pretty good. You know, how many points are there? 1, 2, 3, 4, 5. Maybe there's another graph that would work better too. And so on. You can keep looking at different types of graphs as you go through. So now one of the rules here, and this is a new rule for me too, this just came about not long ago, it says, for any set of n plus 1 points in the coordinate plane that pass the vertical line test, so in other words, in a function, there is a unique polynomial degree at most n that fits the points perfectly. So in other words, n plus 1 points in the coordinate plane. For any set of n plus 1 points in the coordinate plane that pass the vertical line test. So let's look at this one. So if it's 3 points, it's quadratic. If it's 2 points, it's linear, and different things like that. So let's look at this first point here. What polynomial function I have this set of points? Now, we're going to go say, okay, it's 4 points. It should be a cubic graph. So let's go on our calculator, and I'm going to write these points in on our calculator here. Here's our calculator on the screen. What we're going to do is we're going to go to List in Spreadsheets. We're going to label our first list X. Second list, whoa, way to go, new document, I guess. Let's go new document first. New document, no. List in Spreadsheets. Oh, wrong one again. List in Spreadsheets. Now, let's go X, Y. Now on the first list, we're going to put down the x points. Now our x points were 0, 1, 2, and a negative 1. So we're going to put 0, return, 1, return, 2, and a negative 1. 2, return, and a negative 1. Now our y coordinates, we're going to put the y coordinates in there. That correspond to these points. 0 and negative 3. Negative 1, 5, negative 7. So we get the y coordinates here. So therefore we get our points now. Now let's go in our menu. Now this should be a cubic graph because 4 points, 1 less, be cubic. So we're going to go to a cubic regression. Let's start. This is going to be x, tab, y, tab down, and say OK. You know, here's our equation. A is 1, B is a negative 1, C is 2, and D is 3. Negative 3. R squared equals 1. Well, this is R squared meaning 1 means it's a perfect fit on here. So therefore our equation should be, if we wrote our equation out here, and be 1, I'm going to write this down, 1, 1, 2, negative 3. 1, 1, 2, 1, negative 1, 2, negative 3. So it's 1, negative 1, 2, negative 3 is our A, B, and C, D. C, D. So this would be 1x cubed, or f of x equals 1x cubed plus a negative 1x squared plus 2x minus 3. Our point as we go through. So let's look at this next. Let's go to our next graph here. What polynomial function has a graph that passes through these 4 points? This is a cubic again. Now you do the same thing with this one on the graph as you go through. Set these in your x and y and find out your equation. This is a cubic. Now let's look at the one down here. It says, chart shows the milk Wisconsin farms 1950, 80, and 2005. What linear model best fits this data? Use the model to estimate the production in 2000. Well, How do we know it's a linear model? Because there's 3 points. One less than that would be 2. So let's try this one out again. We're going to write down the points here. We're going to go to our calculator. Now, whenever you do the next set of points, what you're going to have to do is you're going to start a new document again. So I'm going to go here, new document. I'm not going to save the one I just did. List in spreadsheets. I'm going to label X and Y. And then my points here are 1955. I'm going to put 1955 in there. 1980. 2005. Y is going to be 16.5. 22.4. And 22.9. X is the year, and Y is that. So now if we go in, we want a linear regression because there's 3 points. We're going to go statistic calculation. We're going to go mx plus b. So we're going to say x. We're going to say y. And we're going to click OK. And we're going to have our linear regression. Not the best fit, but it should work okay. 0.128 and a negative 232. Let's see. 0.128 and a negative 232. So this becomes out to y equals 0.128x minus 232. Now, on here they might have a different, not too much different, but a little different on here, because of the fact that they don't use the year per se on here. So now, on this equation, now what model? Here's our model. There's 2 ways of doing it. We can put in the year just like we read it, or we could put in 55, 80, and 105, and that'll give us a different answer. Next, what we can do is it says, what is the model for estimated milk production in 2000? Well, 2000 means we have to plug in our value here. So y is equal to 0.128 times 2000 minus 232. So if we go back to our calculator, and I'm going to go to calculator, 0.128 times 2000 minus 232, and we got 24. So in the year 2000, it says it should be about the year 2000, it should have been about 24 billions of pounds. So that must have been when the max would have happened, and it started coming back down from there. And that doesn't, is that all make sense in there? Year 2000, if my points are all in there. I'm going to look at my points one more time to make sure my points are in there correctly. 16.5, 22.4, and 1980. Now let's see what happens. They came up with about 23.2. It's a little different, but not too bad. So it's going to be a little different because of how you roll, but that's why you have to define what you're doing as you go through. If 4 data points were given, would a cubic function be the best model for the data? Yes. If 4 data, yes, it would be, because the fact that one less than that is going to give you one of the better fits of the data. Always one less than what the number of points is, following that theorem we have. Here's another one. Here's cheese consumption. It says the table shows the average consumption of cheese per person in the United States selected 1910 to 2000. Use cubic model data of the cubic function, graph the function, and scatter plot. They did that. And we're just going to talk about this. So what they did is they put the values in. They likely used 10, 40, 70, 75, 95, and 101. Since r squared is close to 1, the fit is good. The cubic model is approximately this. So we just went through the whole equation here, plug it in. Now if you want to know how to do that, now instead of using on here, instead of using the year, we're just going to use, let's say 1900 is 0. So this would be 10. Years later, this would be 40. This would be 70, 75, 95, and 101. Now, a lot of books will do this, and a lot of problems we have will do this. So if we go to our calculator, start a new document, don't save, list in spreadsheet, so we're going to go here, X and Y. and go in our calculator and enter these values in. So we're going to have 10, 40, 70, 75, 95, and 101. 95 and 101. And the other part, 4, 5, 8, 4, 5, 8, 10, 25, 10, 25, 30. And go to, now we went to cubic, I believe. They went cubic regression. So menu, statistics, statistic calculation, cubic regression. We enabled our first list X. Second list is Y. Say OK, and if you look at the values, it's the exact same values that they got in their problem because they used these as they went through. So that kind of gets you started on how to use your calculator a little bit as you go through these. I'm not worried about that one. So, let me just read this. Now, I want you to do this question and come up with the model that best fits. Remember, this one right here, I want you to do that one and come up with a model that best fits the data. We're going to work on this a little bit. It's going to take some time to get through all this. Thank you.